today we are going to do another question. Actually, this question is very long, so it might take 2 pages to write this one. So let's see what the question is. So a rocket fires two engine two engines simultaneously simultaneously. Um, one produced. I don't think if you can write one like this. I think you should write ONE, but it does not matter to me. My English is not that great, and if there are any mistakes, um, please tell them in the comments so that other people can know as well. So one produced the thrust of 725 725 newtons directly forward, while um, other gives 530 newtons thrust at and at 32.4 degrees above the forward direction above the forward direction. um, find the find the magnitude and direction of the force of the force which these engines which these engines exert exert on the rocket. So I forgot what I wrote, so let's read it again. So a rocket fires two engines simultaneously. One produced a thrust of 725 newtons directly forward, while other gives 530 newtons thrust at 32.4 degrees above the forward direction. Find the magnitude and direction of the force which these engines exert on the rocket. So the question might sound very tough since it's using a ton of language, but in reality, this question is very simple. It only uses one formula, and that formula is something that you know already. So to make this much more easier to digest, we will do it sim in a simple manner. So let's do this. So rocket fires two engines simultaneously. One produces the thrust of 725 newton directly forward, while other gives 530 newtons at um, 32.4 degrees above the forward direction. Find the magnitude and direction of the force. So let's just make a rocket. I don't know how a rocket looks, but let's try it. Let's say this is the body of the rocket. Obviously, something like a triangle would be a good head of the rocket, I would think. Um, so let's rotate this. Yeah, like that. Let's make it red. I'm just having fun with this one. Like it's there's not a lot of days where I can like create figures, and it's a fun day when you can create figures. So since this has two engines, so let's make two engines. I think I will use squares as engines, and let's make them gray. Why gray? Why not? Right? So that's the first engine. That's the second engine, and let's group this together. Not the greatest rocket, but you understand what I'm trying to convey at least. So let's think this as a rocket. I will take the forward direction to be this, because obviously I can take any direction that I want. Um, the forward direction that I will be taking will be this. So let's write it. So this is forward for me. So this is, I'm supposing that this is the forward direction. And let's go back and see. So two engines produced, one produces a thrust of 275 newtons directly forward. So let's make that. Let's actually move this, since we will have to change this figure. I think we will have to change the figure. So I don't know which color would suit the combustion. Let's make it green. So this is the combustion of the first engine. Very bad, sorry. Yeah, that looks good. So there will be a force going over here, so the thrust produced will be going like this, since this is from Newton's third law, since this pushes back in the same amount that this will. So let's make it white, let's make it a lot more thicker, and this will be our thrust, the first thrust. And I would like to call this thrust F1, because why not? So let's call this vector F1, and this has a magnitude of 275 newtons. So let's write it in gray. So the magnitude is 725 newtons. 725 newtons. So let's go back now. And the while the other gives 530 newtons thrust at an angle 32.4 degrees above the forward direction. So this is the second one. Let's just take this. I'm just gonna assume what is 32.4. Let's say this might be 30. I don't know. So let's say this is 32.4. And let's make it shorter, since this is 500 something. I don't remember. So yeah. So this will be done by this one. So let's rotate this to match it. So like this. So also let's move it. So as you can see, this is our force, our second thrust. Let's make a blaster like this as well. And this is with a thrust of 513 newtons. Let's not do equals to. 513 newtons, and the angle between these two, let's use red. No, let's use what color should I use? Let's use white. This angle between them, so the angle between them is 32.4 degrees. So this is the figure, basically. Not the greatest figure, but I think it's pretty good. So this is the figure. Okay, now we have this, so we need to find the force. So how would the rocket move? Just by looking at this, I think the rocket will move something like, wait, let me rotate this, something like this, something like this. So I think the resultant will go something like that. But to actually find it out, let's just take this vector, and I'm gonna do it in a next page. So remember this picture. Okay, I will do it in the bottom, so it will be much more clear. So let's take the first vector, first thrust, this one, and the second thrust, this one, right? And I think parallelogram law would be the best right now. So I'm gonna use parallelogram law. So take this and that, make it orange, let's make it normal sized, and let's make it dashed, and let's remove the arrows. So I think I see the resultant. The resultant is obviously gonna be this diagonal, not the other diagonal, this diagonal. And let's color the resultant with red. So I'm gonna call the resultant as F vector only, whereas I'm gonna call this down vector as F1 vector, and this blue vector as F2 vector. So F in terms of force, since thrust is a kind of force, you know. So we have this. So I think the question becomes very easy now. The question is literally asking, um, wait, what the question is asking? What is the magnitude and direction of the force? So you just have to use the formula, like, right? You just have to use the formula. I don't think this is hard. Like, even though 10 minutes have gone by, it's because I draw because I draw this. It's not because the question is hard itself. Because if you want it, I can complete this question in like 2 to 5 minutes, I would say. So let's finish it now. So let's do this. I'm not gonna write supposing this, that, and all that, since I'm just gonna suppose that this is that and that is that. So let's do this. So we have the magnitude of force 1 as 725 newtons, the magnitude of force 2 as 513 newtons, and the angle between them as 32.4 degrees. And finally, we need to find vector f. So what is vector f? So I think this is pretty simple. So first of all, let's find the magnitude. So the magnitude of vector f. So if I remember the formula correctly, it's r equals, so r will be replaced by f, square root of a squared plus b squared plus 2ab cos theta, right? So I just replaced a, b, and r by f1, f2, and f. Of course, you can name them any way you like, and if you're doing this more formally, I would also write supposing this, that, and all that, but we are just doing this for learning sake, so I don't care about that. So now let's just keep the values. Square root f1 is 725 squared plus f2 is 513 squared plus 2 times 725 times 513 times cos 32.4 degrees. If you're pretty good at math, I think you can do this in your head, or at least you can do this without using a calculator, but I'm not as smart as you, so I'm gonna use a calculator. So square root of 725 squared plus 513 squared squared plus 2 times 725 times 513 times cos cos 32.4. So when I press the calculator, I don't exactly get the exact answer. So I don't think there is the exact answer. So we will have to do with an approximate answer. So this is the approximate sign. So approximate, and the approximate value that I got was 1190 newtons. Okay, let's just write one decimal point. Nah, I'm not gonna write it. Newton. So a question that you might have is, why did not I write it? I don't know. I just did not want to. I, if I remember significant figures correctly, I don't think I need to add more, but I'm not sure. So that was the magnitude. Now let's find the direction. So the direction of vector f. So the direction of vector f, let's remember the formula. If tan phi, so of course I forgot to say what is phi. Let's call phi be the angle. Let's say phi is this angle, the angle made with vector f1. Obviously if you said that phi was the angle made with vector f2 and vector f, you would have something different, but let's take that. So if I remember, since tan is sine by cos, and here will be theta, and since we are making an angle with vector f1, f1 will be over here while f2 will be over here, right? So we have this is the formula. So now let's just keep the values. So tan phi must equal f2 is 513 times sine theta will be to 32.4 degrees, and f1 is 725 plus 513 times cos 32.4. And again, I'm gonna take my calculator since this is too complex for me. Like, I can't do this in my brain. This is too hard. 32.513 into 32.4 into 725 plus 513 into cos 32.4. I get something, and the something that you get, to get phi, you just need to use tan inverse, which my calculator has as well, thank god. So doing that, I actually get phi to be again not an exact value, approximate value, which is 13.4 degrees. So this is, I rounded up, it was actually 13.35 or something like that, but I think you need, from significant figures, I think you just need three terms. So three terms, and also here like this, since like three terms, also three terms, I think that that's how it works. So we got the angle, and we got the magnitude. So let's write the um, result. Yep, I think it will be result. So the force is around 1190 newtons, and 13.4 degrees above thrust of 725 newtons. I think that is a pretty good way to state it. I think so, but it might not be. But that was it for today's video. In the next video, we are gonna do another question. So there are a lot of questions in these chapters, so we are gonna do a lot of practice problems since there is a lot to be covered. So till then, bye bye.